Hey boys and girls, Mr. D here. In this video we're going to be taking a look at, we have the two goals that we're going to try and look at here in the video. By the time this video is over, you should feel very confident in being able to identify rational numbers and irrational numbers and be able to tell the difference between each of those. And the other thing that sort of goes hand in hand with that is finding and estimating square roots. So jump over here with example 1. Take a look at this one. Goes with goal 2 as far as dealing with square roots. And just so we don't get confused, normally when we see a square root sign, it's actually a little more complete. It looks something like this. We see it in our book. Just the formatting on the computer, it only comes up at that other end. So square root of 25, in order to find the square root of 25, you got to think about what number times itself can give us 25. So we may know off the top of our head, hopefully, that 5 times 5 can give us 25, or even negative 5 times negative 5, that would give us positive 25. So we can just say, hey, the square root of 25, and in this case, what we'll do, unless stated otherwise, we always just use the positive, okay? So we would say the square root of 25 is 5. Sort of working backwards from the perfect squares, okay? So keep that in mind of how to find a square root. So we would say 25 is a perfect square because it has an integer as an answer. If we take a look at example 2, this should say example 2 here. Sorry about that. Come on. All right, so example 2. There we go. We fixed that nice and easy. If we wanted to solve for x, 4x squared equals 120. Well, you guys know, to start this off, we would divide by 4. We're doing multiplication here. We got to get the x all by itself. We do reverse order of operations. So divide by 4. Divide by 4. Okay. Over here, then we have x squared remaining equals 30. Technically, x is not alone here. We have an exponent. So in order to get rid of the exponent, we do the opposite. If we're squaring it, in this case, the opposite would be taking the square root. So if we take the square root of both sides, square root of x squared equals square root of 30. Okay, and then we can say square root of x squared would be x, right? Because x times x gives us x squared. Square root of 30. The square root of 30 is not a perfect square. Right? No number times itself can give us 30. If you think about it, right? We just did 5 squared. 5 squared gives us 25. And then if we did 6 squared, that would give us 36. So if we wanted to approximate, and that's all we're going to do here, when you guys get into some higher level math, we'll really break this down to something more specific. But for now, we're just looking to approximate it to the nearest integer, nearest whole number per se. If we think about a number line here, here's 0. Okay, 5 squared is 25. 6 squared is 36. Well, which is going to be closer to 30? Right? Well, 25 is closer to 30 than 36, so we can just approximate this as 5, because 5 squared will give us 25, 6 squared gives us 36, 25 closer to 30 than 36 is. So we would just approximate this square root of 30 to be 5. Again, square root of 30 is what we say a non-perfect square. It does not have a perfect integer, square root. So keeping that in mind, let's jump over to our second goal. Again, that sort of helps us with our first goal of identifying, our second goal here of finding and estimating square roots. We're working backwards here in a way. But so we just went over how to find a square root. We just went over how to estimate a square root, just finding the nearest integer. So take a look at rational versus irrational numbers. The first thing you've got to understand is there's several different subcategories we could start with, but it all starts with real or imaginary numbers. They're sort of at the top of the food chain here, top of the number chain. All numbers are either real or imaginary. Now, the majority of the numbers you guys have dealt with in your life are all real numbers. There's a very, very excellent likelihood that you have never dealt with imaginary numbers in your life yet. And I know in class we have never dealt with imaginary numbers yet. So for now, let's forget about imaginary numbers. Okay? And let's deal with the subcategory of real numbers. Once we get into real numbers, we can break it into two parts, rational or irrational. Okay? The majority of the numbers that you deal with are rational. Okay? Rational. There's very few irrational. Let's take a look at irrational first so we can figure out what these actually are. There's a couple of things to think about, so please jot this down. I know this is a big chart, so if you need to pause it to draw the basis of it down, pause it, and then let's come back and look at what irrational numbers are. This is important. So there's three aspects that can make a number irrational. A non-perfect square. Yikes, I spelled that one wrong too. Hey, what do you know? I'm looking at it closer. I guess I didn't misspell that. Ah, the beauty of technology. Anyway, so non-perfect square. So for example, we just had one of these here. Square root of 30 we said is a non-perfect square. So that would be an irrational number here. Square root of 30. Irrational. Okay, non-perfect square. A non-repeating, non-terminating decimal. So something that just goes on forever and ever and ever. 0.43698412908 just never ends, never terminates, and it does not repeat. The third one is pi. And if you really think about it, those of you guys and girls that have looked at the poster in the room, pi goes on forever and ever and does not repeat. So it sort of actually falls under number 2. All right, so these are the things you've got to think about when we're dealing with irrational. Okay, so make sure you jot those down. In this box here, I'd like you to give me some examples of irrational numbers. So I'd like you to give me 2 non-perfect squares. Write it in the box. Give me, give me 2 non-perfect squares. Give me 1 non-repeating, and this is an easy one. Just give me an example of pi. All right. So put those in that box there. And then you can press pause while you do that, and we'll come up over here when you're done. You can unpause it, and we'll deal with rational numbers. Okay, so at this point, hopefully, we're all set to look at rational numbers. Rational numbers, again, there's several subcategories we could break it down to. There's actually, we can even get more categories in this, but we're going to deal with these basic ones for now. Integers, no decimals, no fractions. So if you look at this example here, 5 is an integer, right? It has no decimal, has no fraction. Okay, can be positive, it can be negative, doesn't matter. Fractions. I think we all know what fractions are. As long as the fractions have integers in them. So don't give me like 2.4 over 5. Excuse me, make it a fraction. Make it an integer over an integer. So 7 over 11, negative 4 over negative 414, something like that. Okay, if any fraction that has an integer over an integer. That's all rational. Terminating or repeating decimals. So any decimal that comes to an end, 5.43, or even if it repeats, 0.33333333333, etc. Those are all considered rational. So what I'd like you to do right now is please give me 3 examples of each of these. Put them in the box here. Okay, 3 examples of each of these. And I'll be able to check these when you come in tomorrow and check this out. Okay, so this gives us some insight onto rational versus irrational. Again, if you think about it, really the majority of the numbers you deal with are rational except for non-perfect squares, numbers that, decimals that don't repeat and they don't end, terminate, or pi. Okay, so hopefully that gives you, helps you into classifying rational and irrational. Hopefully that helps you estimating square roots. And we'll do some more work on this in class. See you then. Bye-bye.